Good morning. The distributive property. The distributive property really means to distribute or to give evenly. Okay, so today you're going to have to use the distributive property in numerical expressions, algebraic expressions, and also be able to factor those expressions. So here's the lowdown on what the distributive property is. You multiply a sum by a number. Here's the sum. It can also be if you're subtracting inside of here. That's also a sum. You're just adding a negative. We can get into that another day. But if you're multiplying it by what's inside of here, you're multiplying the 2 by the 5 and the 2 by the 6. So you end up with 2 times 5 plus 2 times 6. So in this case, 2 times 5 plus 2 times 6, and 2 times 5 is 10, 2 times 6 is 12, and you end up with 22. And how you would do it back before this day is you would do what's inside the parentheses, and so 2, 5 plus 6 would really be 2 times 11, which would be 22. So why can't I just do it this shorter way? Because the numbers are going to go away, and then you're going to be left with letters. And you have to know what to do. So knowing that this outside the parentheses is going to be multiplied by what's inside the parentheses, both of them, and give you a times b plus a times c, becomes super valuable later. So you're learning just the baby steps right now. Example 1. So, like if we have 2 parentheses x plus 3, you're going to multiply the 2 by the x and the 2 by the 3. So you end up with 2 times x and 2 times 3. And 2 times x is 2x, and 2 times 3 is 6. So if we have here 8x plus 3, you end up with 8 times x plus 8 times 3. Yes, it really does help to write this step. And 8 times x is 8x, and 8 times 3 is 24. Okay, let's do another one where we can make the distributive property work for us even if it's not there. So in this one you'll see 8 times 3.5. Well, we could break the 3.5 up into smaller pieces that are easier to do in our head. Okay, so if we break the 3.5 up to 3 and a half, 3 plus 1/2, and times them by 8, we end up with 8 times 3, which is 24, and half of 8, which is 4, and then add those together to 28. So in this one, we could break the 2 1/4 up to 2 plus 1/4, and then multiply those by 12, and do it in smaller steps. So we have 12 times 2 plus 12 times 1/4. 12 times 2 is 24, and 1/4 of 12, well, what's 12 divided by 4? It's 3. 3 is 1/4 of 12. And then we add those together, 27. Versus the way we learned in a previous lesson this year, we could do it the long way. This is the long way, okay? 12 times 2 1/4 means 4 times 2 is 8 plus 1 is 9. Change this to a fraction and then multiply straight across. 12 times 9. I don't even know what 12 times 9 is. That's a real statement because I don't have that memorized. 12 times 10 is 120, so maybe 108. 108 over 4, and then we can do 108 divide 4. 108 divide 4, 2, 8, subtract 2, 8, 7, 27. Or you could break the 2 1/4 up into smaller things and do it in bits. That's a real benefit to the distributive property. Okay, now if we've got some numbers like this, we can make the distributive property out of this because this is really just a product of two numbers. And we can figure out the greatest common factor of 45 and 72. Do you remember how to do that? 45, 72, 1 times 45, 2 doesn't go into it. 3 does, 15 times. 4 doesn't go in, 5 does, 9 times. And then we can check, do any of these numbers go into 72? Does 45 go into 72? No. Does 15? No, it goes into 75. Does 9? Yeah, 9 goes in here 8 times. So our greatest common factor is 9. That means we can divide this by 9. 45 divide 9 is 5, and 72 divide 9 is 8. And then we can pull those 9s out and put the other two numbers in the parentheses. Which is a lot of talk. Let's do one for real. 80 and 56. 80 and 56. Okay. 80 has 1 times 80, 2 times 40, 4 times 20, 5 times 16, and 8 times 10. 1 times 56, 2 goes in 25, 26, 7, 28 times. 3 does not, 4 does. 4, 56 divide 4, is it 16? Whoopsies. 56 divide 4, oh, it's 14, my bad. Okay, does 5 go in? No. Does 6 go in? No. Does 7 go in? Yeah, 8 times. Okay, so what's the biggest number they share? Oh, 8. They both have an 8. So we could factor out an 8. 8 times what is 80? Yeah, 8 times 10. So that represents this first number. 56. 8 times 7 is 56. Then you can pull the 8 out of both of those, and inside have 10 plus 7. I know this seems long, and where in the world are we going to use this? You're going to use it in algebra. So let's turn the page and use it in some algebra. Okay. If you end up with something like 36x plus 30, let's use the GCF to factor this. So 36 and 30 are going to share factors. Okay, 1 times 30, 2 times 15, 3 times 10, 5 times 6. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So what's the biggest one they share? 6. So we'll factor out a 6. Okay, let's do this side first. 6 times what equals 30? Yes, 6 times 5. Okay, 6 times what equals 36? 6 times 6. So 6 times 6x would equal 36x. And now we have factored out the 6. Where are you going to use that? I'm telling you, in algebra, you're going to use that. This skill right here, super valuable. Okay, let's do one more before we get to our homework today. Martin exercised 4 days for 65 minutes each day. His goal is to exercise for a total of 300 minutes in 5 days. How many minutes does he need to exercise on the 5th day to meet his goal? Well, if he goes 44 days times 65 minutes each day, right? We're going to get a total. And if we take that away from 300, we'll figure out how much he's got to do on that day. 4 times 65. Oh, let's break this up so we can do this in our head. What if we said instead 4 times 50 plus 4 times 15? What's 50 plus 15? 65. Ooh, we probably better have some brackets here. Brackets. Okay, what's 4 times 50? 200. And 4 times 15? 60. And 200 plus 260? Oh, sorry, 200 plus 60 is 260. And 300 minus that is 40. He's going to have to do 40 minutes on the 5th day. And that's how you can use algebra to set everything up and the distributive property to factor that out to make this sum in your head math versus getting your calculator out. It will speed you up later in life. Okay? Good luck.